Yeah, exactly. So if best if someone already has some base improvement, maybe just put a key on top of it, that would be. Okay. So that should be solution out there. Thank you.
So, we're going to get the demo. Let's have you over here.
Well, no, I'm not going to actually put on the head notches.
Oh no, I was going to, because I want to show you this stuff.
Yeah, yeah.
Okay.
Go ahead.
Just write this one down.
Drop this down so that my audience can get a good view of the system here.
There's $1 billion opportunity here for somebody. It's come up with a solution that's better than business cards and sticky tape.
Yeah.
And I bet you would roll right several times.
Yeah. Well, I mean, my steampunk outfit makes me memorable.
Right. So, I'm showing. So we're going.
Yeah.
So we're showing two things today. This is a laptop that has a full desktop 980.
Okay.
So it has the same power GPU as this guy, but in a laptop form factor. And for VR developers, you go to meetups, you know what it's like. If you got to go bring all this to a meetup so you can demo your VR stuff, it's kind of a pain. It's really nice to be able to bring a laptop.
Yeah, because I mean, competing with desk space and power sockets and all that kind of stuff. Yeah, I definitely understand.
Yeah. So it's super convenient to be able to have that amount of power in a laptop. Well, it is a big heavy laptop.
Right.
Make no mistake about it. And then this is the multi-res technology that we were showing yesterday. So what this technology does is it allows you to get better performance from a VR renderer.
Okay. Well, they didn't grant my press pass, so I missed
Okay. So all right.
so yesterday. So I mean, you're talking to my audience. They don't know anything. I don't know anything.
Okay.
So start from scratch.
Okay. So this is GameWorks VR multi-res technology. What multi-res technology does is it allows us to reduce the cost of rendering for VR, which increases the number of graphics cards that can run a VR solution. So to render VR, a typical game maybe runs at 1080p at 30 frames a second or 60 frames a second. For VR, you have to run at 90. You have to run at 90 frames a second because as you move your head around, the image has to keep up. If the image gets behind where you're looking, it can feel uncomfortable. So we're rendering at 90 frames a second, and we're rendering in stereo. So you're having to do a lot more work to render VR than you would to just render a normal game. So we need to get efficiency everywhere we can to make that happen. And this is an advanced technique that uses new hardware inside our latest Maxwell GPUs to achieve that. So what it's doing is this is the left eye in the rendering.
Right.
And then this is what it actually looks like just before we send it to the Optimus. So we've rendered a flat image, and now we have to bow that image to match what the VR headset's actually seeing. The net result of that is that we're rendering this at a very high resolution, but we're also rendering the corners at very high resolution. And those corners actually get shrunk down and distorted and vignetted a bit. So what we'd like to do to save performance is instead of rendering all of this at very high resolution, we'll render the middle, the bit that you're looking at highest resolution, and then these corners will render them at lower resolution.
Yeah.
So that
actually makes sense to me because I mean it's only the center of your eye that has the sharp focus. It's the peripheral vision that's sort of blurred out. So that that's why you move your eyes and why people have the saccades that they're glancing around.
And if we have a headset that had eye tracking in it, we could also track. We could also track that and put the best quality where the person is looking. We're not doing that today with this particular demo.
Right.
So because we can see that the pixel ratio between what we need to display and what we're actually rendering is about 2 to 1, we can actually render this at lower resolution. But the problem with doing that would be if we had to draw the entire scene 9 times, once for each one of these boxes,
Right.
that would be very expensive. So the cool thing about this GPU is that it has it's called multi-view technology, which allows us to create a draw list, a bunch of triangles and shaders and stuff, set up for rendering, and we can send it once and then have it sent to multiple viewports.
Right.
And what's cool about that is it amortizes that cost over the 9 viewports rather than repeat that cost.
Right.
So the net result is we can render faster because we're rendering at lower resolution when we don't need high resolution, and we're not paying the extra cost of that to submit our draw 9 times. So the net result is that you're getting almost double the performance. I'm zooming way in now, and I can turn this off. So that's what the original image looks like. And then when I turn on the multi-res, you can see that it maybe gets a little bit blurrier, the image is a little bit softer, but it's very hard to notice, right? Like there's not a huge difference there. And obviously when I zoom back out, this is way
It's
bigger.
basically on the edge of the banner is where it was really showing up.
Yeah, anywhere with a hard edge. But in practice you don't see it, and it saves a lot of fill rate.
Right.
So if you're a game developer, if you're making VR content, the really cool thing about this is that it means that more people will be able to play the content because they don't need as powerful PCs.
Right.
So rather than needing a 980 or a 970 say to play a game, that same game would probably work just as well on a 960 if you use this technology.
Right.
And the big announcement yesterday was that Epic have taken this technology and they're rolling it into their engine. So if you're using Epic, then you'll basically just get this extra performance boost for free if you're doing VR. And you're running on an NVIDIA card.
Now, tell me about the laptop. I mean, memory, processor, so forth.
So it's a high-end laptop. I don't know the exact specs, but it's pretty beefy. Obviously, you can reconfigure it, and there's a range of laptops. This is a Clevo, but Acer, Asus, and MSI, and a bunch of people are all making laptops with the same graphics card.
Now is this part of the Oculus Ready?
This would be ideal for using with an Oculus, yeah.
Right.
But the part that we're involved in with that is the graphics card, and it's a full 980, and it has direct out, so you get great performance from it. So the trick with laptops is that you need a very high performance GPU, and you need to not use Optimus. So Optimus is power saving technology where you have an NVIDIA card and an Intel card, and you only use the NVIDIA card for your performance applications. Everything else is running on the Intel. The downside of that is it results in latency as the image is coming out of the HDMI, so it adds a couple of frames of latency on the output, which you don't notice normally playing video games and stuff. You wouldn't normally notice, but it becomes a problem with VR.
What about uses for like rendering applications for like 3D modeling and other kinds of stuff? When you're say if I'm doing the content creation stuff, can I? Is it just defined by the area of view in the bounding boxes?
So this technology, the underlying multi-view technology, can be used for anything. So it's not just specific to VR. There's some techniques like cascading shadow maps, and there's some voxel techniques where you want to render the same scene but at different resolutions.
Right.
So you want to have very, very detailed resolution for close, and then further into the distance you're using lower resolution. That's how a cascading shadow map works. So you can have very detailed shadows close, and still have shadows out into the distance that looks good. So that fundamental technique can be used in all kinds of graphics applications.
Okay. Cool.
And then I don't know if you've seen I haven't actually seen this yet, but it seems really cool. You know Tilt Brush, right?
What?
You know Tilt Brush? So Tilt Brush is a 3D painting
Yeah.
application.
Okay. Yeah.
So there is now a 3D modeling app, which is like Sculptress or ZBrush, but in VR. So you can start with a block of clay, and you can start shaving it down and sculpting at it, and actually walk around it in VR. And
Cool.
I really want to try that. I think it's going to be something that's very cool.
I would too. I mean, I'm looking for a program to make it easier for doing, 3D modeling for, creating models to build on my inkjet printer or my 3D printer.
Okay. Yeah. Yeah. So the sculpting with something like Sculptress is a much more natural feeling experience than using a CAD package or using something like Maya. Because Maya and those kind of low polygon modeling tools, the learning curve on them is really steep.
Right.
Whereas something like Sculptress is much more natural because it's like playing with a piece of clay. It's like, sculpting physical materials.
Cool.
So, and I think VR is going to add a lot to that because you can actually be there with it and
Right.
look underneath it, walk around and stuff.
Yeah. It's great. Thanks a lot for the
My pleasure.
demo. Where can my viewers go to get more information on this?
So, oops, there's the card with the URL on it.
Developer.nvidia.com/VR.
Yep.
Okay.
So GameWorks VR.
Hashtag GameWorksVR.
Uh-huh.
Yeah. Great. Fantastic. Thank you.
Do you want a key ring? There you go.
Sure. Save this for my viewers.